Hello everyone, and welcome to our channel. Today, we'll tell you about what the James Webb Telescope has just detected. 400 unknown objects are seen passing by in space. So let's get started. Scientists from NASA and Osaka University in Japan recently did a study that showed the number of rogue planets, which are worlds that move through space without being tied to a star, is much higher than the number of planets that orbit stars. The Nancy Grace Roman Space Telescope, which NASA plans to launch in May of 2027, may be able to find 400 rogue worlds with the same amount of mass as Earth, according to research. In fact, the results of this most recent study have already shown that one of these things could be true. David Bennett, a senior research scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland, and co-author of 2 papers about the study's findings, said, "We think that our galaxy has 20 times more rogue planets than stars. That's trillions of worlds that are wandering around on their own. This is the first measurement of the number of rogue planets in the galaxy that are sensitive to planets less massive than Earth," the expert said. The MOA, or Micro-Lensing Observations in Astrophysics project, was done at the Mount John University Observatory in New Zealand over the course of 9 years. This study led to these conclusions. From where we are, a micro-lensing event happens when an object, like a star or planet, lines up almost perfectly with a background star that has nothing to do with either of them. Light from a faraway star curves around a closer object as it gets closer to it. This is called refraction. This happens because everything with mass changes the way space and time work. The closer item acts as a natural lens, making the light from the star in the background shine a little bit brighter for a short time. This gives scientists information about the object between the stars that they couldn't get any other way. Microlensing is the only way we can find objects like low mass-free floating planets and even primordial black holes, says Takahiro Sumi, a professor at Osaka University and the lead author of the study that gives a new estimate of the number of rogue planets in our galaxy. The paper gives a new estimate of how many rogue planets there are in the Milky Way. It's very cool that we can use gravity to find things we could never see directly. Scientists found a rogue planet with the same mass as Earth. This is only the second one of its kind to be found. The Astronomical Journal will print the research report that explains the discovery in an upcoming issue. In the same journal, there will be a second study that looks at population data and finds that rogue planets are 6 times more common than planets that follow stars in our galaxy. We used to wonder if planets in our solar system were the only ones in the universe. In just a few short decades, we've found more than 5,300 planets outside of our solar system. Most of these newly found worlds are either very big or very close to the star that hosts them. On the other hand, the team's results show that rogue planets are likely to be on the small side. Sumi said, "We found that rogues that are about the size of Earth are more common than ones that are bigger. The difference between the average masses of planets that orbit a star and planets that don't orbit a star holds a key to understanding how planets form. Putting together a world can be a very chaotic process because of all the growing celestial bodies will pull on each other as they settle into their orbits. Because their star's gravity isn't as strong, planets that aren't very heavy are more likely to be thrown out into space by the interactions explained below. This is the start of a life spent alone, hiding in the shadows between stars. Micro-lensing events show that lone planets are very rare. So one way to find more of them is to throw a wider net. When the project finally gets going in May of 2027, Roman will do just that. Since Rome will be in space, it will be able to detect even rogue planets with less mass, says Naoki Kishimoto, who led the story about the possible discovery of a rogue world with the mass of Earth. When he was an assistant professor at Goddard College, he did this study. He now works at Osaka University as a teacher. The researchers said, with Roman's wide field of view and sharp vision, we'll be able to study the objects it finds in more detail than we could with only ground-based telescopes. Roman's broad view and keen sight. Based on planets found around other stars, the best predictions before Roman were that he would find 50 rogue worlds with the mass of Earth. According to these new results, it might be able to find about 400. but we won't be able to make more accurate predictions until Roman starts scanning the skies. Scientists will mix the Roman data with ground-based observations from places like the South African Astronomical Observatory in Sutherland, where Japan's PRIME or Prime Focus Infrared Microlensing Experiment telescope is located. This 1.8-meter telescope will build on the work done by the MOA. It will be the first to do a wide-area microlensing study in near-infrared light. As part of an international deal with the Japan Aerospace Exploration Agency, or JAXA, it has 4 detectors that were made as part of Roman's detector development program. NASA gave these devices to scientists. Every microlensing event is unique, but scientists can't go back in time and make the same observations again. But they don't happen right away. A microlensing signal from a rogue planet can take anywhere from a few hours to about a day, Kishimoto said. Astronomers will be able to use both Roman and Prime to make observations at the same time. Scientists will be able to measure the masses of rogue planets much more accurately than ever before because they can see them from both the Earth and Roman spot a million miles away. This will help us learn more about the worlds in our galaxy. Webb also finds small amounts of water in the atmosphere of an extremely hot gas giant. Scientists found water vapor in WASP-18b's atmosphere and made a map of the planet's temperature as it went behind its star and came back again. This type of eclipse is called a secondary eclipse. Scientists can look at the light coming from both the star and the planet. When the planet moves behind the star, they can use just the light from the star to make more accurate readings. The same side of WASP-18b always faces the star. This is called the day side. The same side of the moon always faces the Earth. The temperature or brightness map shows that there is a big change in temperature, up to 1,000 degrees, from the hottest spot facing the star to the terminator, where the day and the night sides of the permanently twilight planet meet. The experts made a map of the temperature changes on the day side of the planet. Given how much cooler it is at the terminator, it is clear that something is stopping winds from moving heat to the night side as they should. The WASP-18b brightness map shows that there are no winds from east to west. One possible reason is that this planet has a strong magnetic field, which would be a very interesting find, said Ryan Challenger, a co-author from the University of Michigan. And that's it for today, guys. Hope you enjoyed the video. Leave a like and comment down your thoughts on this. And don't forget to subscribe to the channel. Thank you for watching this video.